But before we kind of jump into the section, does anyone have any questions regarding maybe 11.1 or quizzes, anything with the class, anything at all?
I have a question. Would you recommend that we actually do the online homework before we do the quiz, just so then we get used to what it wants from us to answer and stuff like that? Because I think
Yeah,
the reason
no, mm-hmm.
is because of that.
Yeah, no, I would definitely recommend looking at the homework before you take the quiz, mainly just to see kind of how the questions are laid out, you know, exactly what you said, like how they want their the answers and everything like that, because like I've said before, your quizzes are from my math lab and they're basically just homework problems given to you with different numbers, slightly different functions, but they're the exact same thing as what you see in the homework, as what you see in the online homework. So it would be hugely beneficial if you did work through those online problems first and then take the quiz.
Okay, cool. Thank you.
Yeah. Anything else? One other thing that I would say, Pearson is obviously very overloaded. That's the company that runs my math lab. Very overloaded with a lot of professors putting all of their content online. And so there have been a few issues with the courses shutting down or blocking you out. But that is usually in the later evening. So if you guys are doing the problems, taking quizzes earlier in the day, you're less likely to encounter those problems. So that was one thing I wanted to say really quickly. But are there any other questions for me? Okay, so if not, then we will get into the section. Okay, so 11.2, this is just for part A, mind you, but 11.2 is dealing with the exact same thing we saw in 11.1, but rather than looking at increasing versus decreasing like we did in 11.1, we're now looking at concave up versus concave down. Okay, so this was 11.1, this is 11.2. Now, does anyone want to remind me, how did we get increasing versus decreasing in 11.1? What did we use to find those intervals? Anything about the function, anything like that? Okay, so for increasing versus decreasing, we look to our first derivative. Okay, so this is just our regular derivative that we've seen before, f prime of x. And when f prime of x is positive, that's when we're increasing. And when f prime of x is negative, that's when we're decreasing. Right? This should all be hopefully familiar for you guys. So now we're taking that same idea, but we're doing it with concavity. Okay? So increasing versus decreasing first derivative, you can kind of see it in the name here. For concavity, we're going to look to our second derivative for concavity. Okay, so same kind of way. When the second derivative is positive, so this is kind of backwards, but greater than 0, we are concave up, kind of writing this weird. Okay, and then when the second derivative is negative less than 0, we are concave down. Okay, so the way that we can remember this is concave up. That looks like a bowl, okay, like a smiley face. And so the way that I keep this straight in my head, let's make sure I'm not muted or anything. That would have been awkward. Okay, cool. So the way that I keep this straight in my head is when we are concave up, that kind of looks like a smiley face, right? Something you would make back in the day. So concave up, that goes with when we are positive. So when you are positive, you are smiling. Okay, so that's kind of how I keep that straight in my head. Concave up, second derivative positive. Smiling, you're happy. Same kind of thing. And then concave down is just the opposite. Ugh, if my pen would stop glitching here. Okay. So it's just, it honestly is like a reflection. Concave down and concave up are opposites. Okay, cool. So the process for doing all of this is the exact same idea as in 11.1, but now we're looking more at the second derivative. Okay, and 11.2a is more so just dealing with graphing given information about the second derivative and the first derivative, and then just finding second derivatives. We're not doing much with looking at concavity just yet. But do you guys have any questions that you know of off the top of your head that you want to go over?
I was wondering if we could look over the MyMathLab of 47 on 11.2a.
Absolutely, yeah. So 47, okay, so let's see what that problem is asking for. Okay, so I'm actually gonna switch here really quick. If you just give me a second. So what we're gonna do, we're gonna try something a little different, maybe. Just kidding, apparently that's not an option. Okay, never mind, ignore me. Okay, so let's write out this information that we have. So first off, we're just given x and function values. So -3, 0, 1, 2, 4, and 5. Okay, and then corresponding functions values for each of those. Okay, awesome. And then we are given information about the first and second derivative in the form of sign charts, which are really nice because we've seen those before. So we have first and second derivative sign charts, and we are looking at 0, 1, and 4, and 0 and 2. Okay. So at 0, our first derivative is not defined, and same with our second derivative. And then the rest of these are 0. So quick question. What do we call these guys here, where the first derivative is equal to 0 or not defined?
Aren't those the critical numbers?
Exactly. Awesome. Yeah, just a little refresher there. Okay. And then the values in between these, we are positive and positive, negative, positive, and then positive, negative, positive. Awesome. Okay. So let's just start off with plotting our points here. Okay, so we're gonna go down here, have my axes. Okay. And arrows are not important, but I like them. And add them. Okay, now given our values that we have here, what do you think we might want to increment by? Not really necessarily a right answer here. One half, 1, 2.
Maybe try by 2.
Sure, yeah, absolutely. So our max value is 5, so we want to leave room for that guy. And just to make graphing a little bit easier on myself, I'm just going to put little hashes in between so I can find those values faster. Okay. So our first set we have here is -3, -4. So we're going to go over to -3, down to -4 right there. And then 0, 0, that's pretty easy. That's just the origin. 1, 2, right there. And then 2, 1. So kind of tight together, but we'll zoom back in a second. Okay, and then 4, -1. And then finally 5, 0. Okay. So those are our points. Try to make these a little bigger so they're easier to see. And they're kind of ugly, so apologies, but it's just how it's gonna have to be. Okay, awesome. So now that we have all of our points plotted, let's go up to our sign charts, okay? So, what does the derivative being positive tell us? Had it up here.
The slope is increasing?
Exactly, yep, increasing. So I'm gonna represent that with a little upward pointing diagonal line, okay? And then the same thing here, we're gonna be increasing. I'm just gonna erase that. And then we have another positive, so we're increasing. And then what about here where we're negative? What's gonna be going on there?
Is the slope going to be decreasing?
Decreasing, exactly, same kind of idea. And those lines just kind of help me get a general idea of what my function will be looking like, okay? Now, what about here when second derivative is positive? What do we know about that?
It's smiling. It's positive, concave.
Yes, exactly, exactly. So here, when we are positive, we're smiling, so we are concave up. Same thing here. And then here, concave down. So I just like to do those little sketches with my sign chart to kind of get a pretty good idea of what my graph should look like without having to touch the actual graph at all. Okay, and now we can move back down here. So first thing I like to do is use this information about my critical points. So at 1, we have a slope. Actually, I'm gonna, sorry, keep switching colors on you. I'm gonna do a little dashed horizontal line. And again at 4. And then what do we put at 0 if we're doing not defined? Do you think? What could we do? So remember that a vertical line has an undefined slope. So whenever we're talking about a slope that's not defined or where our first derivative is not defined, we can just put a little dashed vertical line. And that will kind of get us a good idea. Okay. And now let's look to this part where we drew our little sketches. Okay, so from negative infinity to 0, we are increasing. Okay, and then again from 0 to 1, increasing, 1 to 4, decreasing, and then 4 to infinity, increasing. Okay, so we're starting to kind of be able to see our graph just right there. Okay. And now with the concavity, the best advice that I can give you is just to try to over exaggerate if you can. Okay, so we are concave up, so we're gonna have something kind of like this, and then we're gonna go vertical. Let me kind of redraw that. It's not quite so messy. Gonna go just slightly vertical there. And then we're gonna switch to concave down. And we're gonna stay concave down through to 2. And then we're gonna go back to concave up. Okay. Do you guys kind of see how I sketch that? Are there any questions about the graphing part?
So whenever we're using going positive, we always want to make it a concave kind of like curve, not try to make it almost like a parabola, just or parabola pointing down like a frowny face. Just always make sure it's caved based on the positive and negative aspects of the double derivative.
So what I would tell you is anytime you have, so like here, concave up, this portion on this side is all talking about decreasing, okay? And then this portion on this side is talking about increasing. So wherever you have a slope where you're increasing, but you're concave up, you wanna look at this half of the curve, okay? So unless you have something like this where you're switching, actually, oh yeah, no. Where you're switching from decreasing to increasing, that's the only time you'll ever get a full parabola, is in one of those spots where you are switching from increasing to decreasing. Anywhere else, you're only really gonna have half of it, just one side. Does that kind of answer your question?
Yeah, that does. Sorry, it's kind of hard to ask it when
No, that's okay.
we're not in person, you know.
Yeah. But yeah, so that's graphing. And a lot of this with my math lab will probably be mostly matching. You know, they'll give you 4 graphs and you pick the one that best matches the conditions. And I would say first and foremost with those type of problems, look at your points, because if you have any graphs that don't have one of your points, then you automatically know that that one's done. And then you want to go to your first derivative, since you guys are a little bit more comfortable with first derivative now, having seen it twice, well, seen it a few times, but now seeing the increasing, decreasing twice, you can kind of see based on the options you're given, which one matches that. And if you have one that just has it increasing where it's supposed to be decreasing, you know you can get rid of that and then go to your second derivative. So that's kind of the process that I would take going through those answers. But other than that, I think you guys have a pretty good handle on how my math lab formats stuff by now. Probably most likely a lot better than me, since it has been a few years since I have been on my math lab. But Any questions about this problem at all? This is kind of the main bulk of 11.2a. There's not a ton past this. Okay. Well, why don't we go through a problem where we have to find the second derivative so that you guys can kind of get practice with that. Unless anyone else has a problem off the top of their head that they know they want to go over. Okay, sounds good. So let's go over something where we're finding the second derivative. So, or is that more? Oh, that's actually more 11.2b. Sorry. Yeah, 11.2a is just entirely dealing with this kind of stuff. Using the information and then finding a graph, or vice versa, you know, looking at a graph and being able to get this information. So any questions at all? Anything for me? Not a ton to this section. Okay, well, if you guys don't have any questions, I really don't have a lot more that I want to go over. This was the main bulk of it. You guys got to see a first derivative that is undefined. Got to see switching from concave up to concave down, switching from increasing to decreasing, graphing. So I feel pretty good about all of it. But if you guys do have any questions, you can stick around. I'll just have Zoom open until 2. But if no one has any questions, you are free to go.